Yes. Yes. Small lowercase b. That's weird that that's still going forward. Oh, I see.
That's broken the tree. I'll try to
Oh, is that? That's weird.
Oh, yeah.
It's just a slideshow.
How about I turn off the slideshow?
Yeah. And how about all of these scanned purchase receipts in my head?
We ready to do this? Awesome. So, welcome to the May.
Yes, it's May.
May, thanks. Welcome to the May meetup for DevOps KC. Tonight we have Chuck all the way in from Seattle to talk about. Did you say Kubernetes or Kubernetes? Kubernetes. Okay, I say Kubernetes just to be confrontational. But he'll be up here in a second.
Is that better?
That's
You look official.
Oh yeah.
Yeah, you're on stage. Dazzle.
As always, follow us on Twitter. And thank you to everybody that subscribed to our YouTube channel so that we can have like a really pretty link to just be like /DevOpsKC instead of a bunch of numbers that nobody knows what they mean. We'll post tonight's proceedings and the future ones on here. So if you ever can't make it, try to make it. This is an awesome turnout for this meetup. But if you can't, we're attempting to live stream each time. You know how that goes.
Best effort.
We're doing better. Like we set the bar real low, we're getting better over time. And then we also record them and edit them and put them up. If you're not in Slack, join the conversation. You can invite yourself by just going to DevOpsKCRokuapp.com. And if you want to help with planning this meetup in any way, there's a planning channel, and we just pretty much openly talk about like what we're doing. There's no secrets or anything. Anybody can join that and help out. If you want to speak at a future meetup, we're on paper call. So just put your ideas out there. You can start with just like, here's my idea for a talk. Or you can have like a talk that you want to test out for a future conference or whatever it is. But like, let us know what you want to talk about. We've got some on there that I'm trying to think through, like, how do we use those? Like, do we vote on them? So if you have ideas on that, because there's some really good talks in our backlog here, and we want to figure out like what we want to do in the future. DevOps Days KC will be September 21st and 22nd at the Uptown Theater. We're super stoked about this. The CFP is open until the end of June, but don't wait till then. We're already on pace for possibly about double the amount of submissions we had from last year when I look at the numbers. But that doesn't mean don't submit. Like continue to submit. We want to put on like the best show possible. The venue's a lot bigger this year, so last year we were pretty much right at the capacity of what it could be. This year we want to really grow into this new place. So and tickets are definitely on sale. The June meetup, again, that planning room. This is kind of up to you guys what it is that you want to do. We can do anything really within the realms of like DevOps or whatever. So, not anything. We'll probably talk about like DevOps things. We won't talk about things like that. We could. I don't know. And a huge thank you to our sponsors tonight. Balance Innovations got the Joe's Kansas City barbecue, and it's awesome. Were there any vegetarians that didn't get one of the Portobello Seamans? No, we got it covered. Awesome. That thing is delicious. I had to hold myself back from not eating it to make sure we had that. Red Hat also provided the speaker that we'll see in a minute. And things that are upcoming, besides this Saturday, I believe the tickets are sold out. But if you talk to people really nicely, you might be able to sneak in, or like buy someone's ticket that's not going to be able to make it at the last minute or whatever. So join the SecKC Slack and talk about that. I've already seen a couple people post like I really meant to get tickets, but I didn't. So talk through that if you wanted to go. KCDC, the speakers are up for that. What's up?
What is B-side?
What is B-Sides?
Yeah.
It's very similar to DevOps Days in that it's like a national franchise type of local conference. So I believe they have one in Des Moines. They have them like across the nation, Seattle, Florida, all over. This is the second or third time they've done it in Kansas City, but they haven't done it here in Kansas City for a few years. Does anybody know what the venue is? It's one of the ones downtown, one of the co-working spaces. I think big. And it is sold out, so you'll have to get a ticket from someone that possibly isn't going to go.
You mentioned that it was security related.
Security related, so IT sec,
Okay.
type of stuff. So
The schedule's out, so you can go to that.
yeah, the Dan speaking.
Aaron speaking.
That's true. So that'll be fun. I think it's 2-track. It's pretty cool.
Yep.
And then so that's IT security, and then the developers conference, KCDC, is in August. They also have their schedule online, and you can buy tickets for that. I think it just went on sale a couple days ago. And of course, DevOps Days, KC. So does anybody have any other announcements of things coming up that we should know about or participate in? Yeah.
My company, Technology Group Solutions, is actually sponsoring the inaugural Ansible Kansas City meetup the 24th at 7 o'clock. So it's on meetups.
Awesome. There's an Ansible meetup now.
Yep. This is the first one. So yeah, it'll be, it's probably going to be kind of a high level to start. And it's a little late, but hopefully we can start directing that content as people desire. So
That's
feel free to
super
sign
awesome.
up if you're interested.
That's May 24th,
Correct. 7 p.m.
7 p.m. Where at?
The Technology Group Solutions office, which is like 85th and 23rd.
Oh, awesome.
What is today?
The 16th.
16th, so it's next week sometime.
Next week. Wednesday?
I think it's
Thursday?
Wednesday. Sorry, Wednesday the 23rd.
I thought it was like in a couple days, so a little off.
So yeah, if you're on the Slack, we try to post everything that we know about in the upcoming events. For sure, post that. And for those meetups, there's a Docker meetup starting. We'd like to do joint things where we bring, I think we just crossed over 800 people that have joined the meetup.com site for DevOps, which is awesome. And we've had talks in the past about Ansible and about Docker, Docker and Kubernetes. So we definitely want to work with all the other meetups. It's not a competition. It's really about like getting the best content we can, so all of our companies can succeed. Anybody else have meetups? Anybody hiring right now?
Clinical reference laboratories, hiring sysadmin, Linux, and
Clinical Reference Laboratory?
clinical reference laboratories, CRL,
Awesome. We also have a channel for that, for jobs on the Slack thing, so definitely help each other out.
We're hiring. So my name's Todd Schutz. I'm a member of the Balance Innovations team. So just first of all, welcome to Balance Innovations. Glad everybody can make it. If we can do anything for you while you're here, please ask. We are hiring as well. If you know your garbage bins, brothers, sister, whatever, anybody from a technology space, we're hiring. Folks from a cloud infrastructure perspective, developers, testers, pretty much across the board. So if you know of anybody that's interested, please look us up. Appreciate it.
How about a huge round for Balance Innovations? You guys have been awesome to work with. Like,
Yeah, it's been great.
Thanks.
today we were like, what are we going to do about food? No, yeah. Oh,
Yes. I was like, what else are we gonna do? You want pizza? Forget it.
Cool. So I'm going to hand it over to Chip to do short what is DevOps for us, for any of the new people. By show of hands, who's new to this meetup? Awesome. Who's new to DevOps? Roll it.
I was.
So, welcome everybody. This is something you guys started a few months ago. Have somebody get up and just do 5 minutes on what is DevOps. So I volunteered tonight. My name's Chip Warden. You can reach me there. If you hate everything I have to say. So, how many DevOps engineers? DevOps engineers. Sorry. So, and I also want to apologize because I'm basically doing the worst possible thing, which is my slides say everything I'm going to say, which is really a bad way to do a presentation. I apologize, but I threw this together last minute. So anyway, DevOps is a process. It's not a person. Now, having said that, my last position, I was a DevOps engineer. That was my title. Now, luckily, my new boss didn't give me that title. So, yeah. But I still largely do the same things. What about SRE? Anybody in SRE? Anybody knows what SRE is? Okay, good. That's just Google speak for DevOps engineers. So that's, let's just face facts. That's what it is. So, as I said, what do? My title used to be DevOps engineer. So what do? I do a lot of things. Include some of these things, but not just these things. Create automation. Well, that's kind of part of what we call the DevOps process, right? I write software. There we go. Write documentation. I research off-the-shelf solutions, proprietary and open source. A lot of times it's better to buy than build, or to adopt something that somebody else has already built, rather than build it yourself. What I really do, what I really like to think I do, is solve problems. Now, my boss may say I cause problems, but and he's laughing right over there. So, and the other thing is I try out new things, which is cool. So I've said, DevOps is a process. What is it? Sorry, guys.
New laptop?
Yeah, exactly. So DevOps is an attempt to bring together development and operations to achieve better outcomes. Now, what are the outcomes? We're doing software, right? So the better outcomes is better software. That could be for external customers, that could be for internal customers. Who knows? But that is the attempt. What does that mean? And again, DevOps is a process. It's not a defined state. You can't have DevOps done. That's not how it works. It's not a finish. Oh, checked off these boxes, and now we're DevOps. Yay! So that's not how it works. Now, DevOps can include the CDs and the CIs. It can include that. It can include chat ops, development tools, systems automation, infrastructure as code. I kind of got a problem with that too. Observability. I think we all like that. Could be microservices, although I remember when it was service-oriented architecture. But and could be containers, could be VMs, could be cloud and or serverless computing, another terrible name. But that's the thing we have. But in and of themselves, these things are not DevOps. They're just part of the process we call DevOps. But there's some other things that, to me, are part of the DevOps process too. Like responsibility, like ownership.
True.
These things are important. Teamwork, obviously. Knowledge sharing. To me, this is one that gets overlooked a lot. We've all, if you've been in the IT software, if you've been in the software biz a long time, knowledge tends to concentrate on somebody and then they're out the door. DevOps should try to avoid that. DevOps should try to bring that collect that knowledge to all the people on teams rather than just a person on a team. Mentorship is part of knowledge sharing, but it's also apprenticeship. The cliche of if you're the smartest person in the room, it's time to find a new room. There's some truth in that. So you should always be trying to improve. Professionalism. This is not letting it slide because, well, it's Friday. Not trying to build up the hero thing, but it's just saying, hey, things need to be in a state of operation. Kindness. It's kind of gushing, I know, but don't just be a jerk to people if they mess up. Don't, it makes people shut down and it makes learning from mistakes very, very hard. Empathy. Hey, when your boss, or what's more likely, the owner of a different project comes and say, hey, something you guys did screwed us up. Try to take a minute and put yourself in their position. Not saying they're right, I'm just saying try to see it from their point of view. And understanding. That's, everybody has an off day. Try not to dwell on that. Try to, help people with, to me, these things are at least as important as any of the technologies that are involved. Had a meeting with the CIO where I work today, and she was very adamant about the fact that a lot of software, what we do, is person to person, and I flat out believe that. You may be in a distributed work environment where you're working at home or in the coffee shop or whatever, and your actual boss is in California or wherever. But you still need to have those personal connections, and these help that. So anyway, thank you for your time, and I'll turn it over to our presenter tonight.
And if you like that, feel free to contact me, and I'll try to find a good job on our team. Good advertisement, man.
Check. Can everybody hear me? Alright, so I'm going to use my voice is really low. Right. So before we start, I would like to get a quick feel of what kind of background we have. So how many of you have got like hands-on experience with Docker? Okay. And Kubernetes? Okay. And OpenShift? Okay. Yeah, so whatever we talk today is pure open source tools out there which are changing the day-to-day life of operations and also developers. So we focus more on Kubernetes and a little bit of OpenShift as well. Okay, so OpenShift by means OpenShift Origin, which is like an open source version. Okay, so my name is Chetala. You can call me Chuck. I work at Red Hat. As part of my job, I get to meet a lot of customers around the US and Canada. I help customers in bringing in container orchestration into their organizations. So for this role, it helps me a lot to understand organizations and then what kind of steps they are taking in to adopt containers in their organizations. Okay, so that's one aspect of what I do. I'm also a Cloud Native Compute Foundation ambassador. Are you aware of CNCF? Right. So it's a part of Linux Foundation, but it's more focused on cloud cloud native applications. So I'm an ambassador of that as well. So and also I'm from a developer background initially, like more of Node.js type of things, and also a bit of mobile, but not really like operations. I've been doing Docker and then operations most probably from two years now. Right, so this will be our short agenda. We'll do an ultra short introduction to what Docker is, Kubernetes is, and OpenShift, and then we'll do a Kubernetes / OpenShift demo. It's the same thing when you talk about OpenShift. Think of it as again Kubernetes. When I talk about Kubernetes, it's the same thing. Okay, I'll tell you the difference, but we'll do an ultra short demo of Kubernetes and then what containers are. And then this is our major focus, installing Kubernetes from scratch. Like there is a better way to install Kubernetes, very easy way to do it. But what we are going to focus today is basically understand each component of Kubernetes, how it works together. Okay, so installing from the scratch with a goal of understanding the components of Kubernetes. That's what our real focus is today. So feel free to stop and ask questions if you have any. Like to keep it interactive. So these are the buzzwords today, right? So Docker, Kubernetes, and OpenShift, right? So we'll look into each of these and then jump into the installation part. So what exactly is Docker, Kubernetes, and origin? I would like to give some analogy, right? Everyone likes analogies. So think of Docker as a packaging system for your applications to run inside containers, and basically it's a process. Your application will run as a process, but that process is a controlled process. So you can control how much CPU, how much memory, and how much like resources it will consume, and it has its own file system. It has its own IP, like network, all these pieces. All right. So it almost looks like a VM for you, but ultimately on the course it is basically a VM. It's basically a process. All right. So you get a lightweight virtualization for your application. That's what Docker is all about. All right. So when you want to run these Docker containers on a single machine, it's fine. But when you want to span these containers for application across multiple hosts or thousands of nodes, you use some kind of orchestration tool. That's what Kubernetes is all about. Right? So I have a simple analogy. Most of might you agree or may not, but think of Kubernetes or like Kubernetes as your kernel for your data center. Let's say you have 1,000 nodes in your data center. For those 1,000 nodes, Kubernetes is like your kernel, right? So what I mean by that is you never have to go into each individual machines to deploy applications. You always talk to your operating system, which is your OpenShift, or in this case, and this will basically assign or take care of all the orchestration for you, all right? So this acts as a kernel for your data center, whereas OpenShift acts as a operating system for your data center. So the ultimate analogy or what I want to convey here is, in order to deploy applications into your data center, you never have to go into each individual machine. You always talk to an API, and this API will take care of deploying your applications for you. All right. So that's the simplest analogy I can give. Any questions on this? All right, cool. Yeah. No, so VMware is totally there are different. Let's say your application virtualization, it comes somewhere in this area, but not truly like it will not replace whole VMware thing. It might in future, but as of now it won't, right? So it comes around this area, like your application virtualization. So if you do some math, or like just to make it simple, your OpenShift, you have Docker containers, you have Kubernetes, plus some awesomeness. I'll discuss what that awesomeness is. Okay, so this is the kind of analogy I would give to any person who wants to understand what exactly it is. Right. So we'll come to this part after some time. Basically, what exactly I'm talking about when I say awesomeness is you get basically when you deploy applications into your data center, you actually need some kind of security around that, some kind of networking around that, and centralized logging, developer tools to deploy applications, registries, your incoming load balances, and also application monitoring and as well as system monitoring. All these things will be needed, right? So those are the pieces that we're going to address. So with that, let me go into why exactly we are discussing all of these new tools now. Right. So have you heard of this anytime? Right? But it works on my machine. So most DevOps folks will hear this because this is like a day-to-day conversation between developers and operations. I used to be a developer before, so I know pretty much this is what happens. What is the primary reason for this? It's because when developers hand over code to operations, they think it works on the machine and then it should work on in any other environment. But when it goes to actual operations, this is what they see, right? It doesn't work. So the real cause for this is, we'll discuss the real cause and then we'll address the solutions. So the real cause is this. Your development environment might be something on Windows, or you have some apps sitting side by side on that. Whereas in QA, it might be a different environment. In production, it might be a different environment. So this is the primary reason your applications like development teams and operations teams, they kind of have a friction between them to bring in changes, right? So what if you can package my operating system, my middleware, and my application all together in one single binary? So I can avoid that friction if I can package that, right? So that's the reason we kind of moved from this method to that method where instead of providing a WAR file or a artifact, you provide the entire stack, which is operating like your operating system, middleware, and also your application as one single binary. Because these all things are in one single binary, you avoid a lot of issues in moving your apps from dev to QA and QA to prod, right? And also, what if I can treat each process on an operating system as one single VM-ish, not exactly VM, but it has its own network and all this. So that is what Docker is, right? So it brings a lot of lightweight application deployment strategies. So instead of deploying, let's say, 20 applications for your operating system, now you can deploy maybe 50 applications, right? So just to compare the numbers. So because you're no longer having that heavyweight operating system virtualization there, you are just treating your process as your whole VM, right? So when you move that into that direction, you get a lot of density for your existing hardware. Okay. So this is what it looks like when you deploy applications using Kubernetes or OpenShift, right? So this is what it looks like. Every application is basically a Docker container running inside your entire data center. No longer you have like this is Java, this is PHP, this is Node.js. No, everything is like a Docker container. It makes the operations job easy because I can just focus on like deploying Docker images, right? Instead of bootstrapping each VM whenever some developer asks for a environment, I need to go and then bootstrap every time, right? Instead of doing that, I can just do this activity one time, which is writing the Docker file, and after that, it's ready to go, right? Of course, you need to maintain that. No one is denying that, but it makes it makes developer operations jobs more easy than compared to the previous model. So, so let's think of your data center has like 4 VMs, just for the sake of example. You never have to go to like this is the traditional way of doing it. You go and bootstrap each machine by switching or maybe using some Ansible or some kind of chip, right? Whereas if I can deploy these, like bootstrapping takes a lot of time. What if we can deploy in minutes rather than waiting for days to complete this activity? So this is a pretty good use case for us. And also, moving applications from one machine to another machine is pretty hard. Why do you want to do that? It's all about flexibility, right? I'll discuss in more detail in the future slides. So this is again like restarting applications. It's very fragile. You cannot really like do this confidently. All these things will take into consideration. So what if I can treat my whole data center as one single machine? I never have to go into each individual machine. So that's what is OpenShift or Kubernetes, right? So this is what the analogy is. So your whole data center, your kernel, your operating system, and you are basically acting from here. So issue your commands from here, and everything should be taken care of. You don't need to worry about what exactly, as a developer, you don't need to worry. As an operations, we definitely look into the cluster health, but even for operations, you will basically abstract a lot of these things. You never have to worry about single individual machines. You just need to worry about the entire cluster right now. So this is like an analogy again. Let's think of like 6 nodes. You want to deploy some applications. These orchestration, the Kubernetes or OpenShift can run basically on any type of hardware. So this is again Kubernetes also. So these all machines are connected with a software-defined network. This is like a only network which is accessible inside the cluster, not outside. I will discuss more about that. And your applications will run as basically Docker containers, right? So this is a real example I want to give you. So as a developer or operations folk, I want to deploy 3 applications, 3 instances of my Tomcat application, right? That's my goal. I just talk to this API, okay? That is Kubernetes API. Under the hood it shows OpenShift, but it's under the hood it is Kubernetes API. So when I say that API, I need 3 instances of my app, then what Kubernetes or OpenShift does is it looks at the entire cluster. Based on the resource availability, it goes and schedules these applications on these machines, okay? So that deployment part is taken care by, that deciding which machine to deploy is taken care by Kubernetes. You just need to say, I need 3 instances of this, okay? And you can also specify where your application can land. Let's say this Tomcat application is very disk incentive, and you want to deploy this application only on nodes which has SSD labeled, right? Like nodes which have SSD as a disk for them. So you can label them and then put a constraint here that disk equal to SSD. Then it will reshuffle and then deploy only on those nodes which are having SSDs on them. Okay? So it's pretty flexible environment. And all these application instances are automatically load balanced by a service, internal object called service, which is a part of Kubernetes itself, right? So service is like an internal load balancer for your Kubernetes cluster. And you also get a internally discoverable name, which is a DNS name that you get for your application. So this application is Tomcat application, and you get an internally discoverable name. And if some other application wants to communicate with this application, it can just use the internally discoverable name to communicate with that. Okay? This is all happening inside your cluster. And you want to scale your application, you issue another command to your API, and then Kubernetes will take care of scaling this application for you. Right? It will find out whichever node is like having enough resources, and then you go and deploy there. Right? So that's what happens. What if a running instance has some issue and then it dies? So usually now you have to go and fix in the middle of night, but when you use Kubernetes, it automatically fixes that, and then if needed, it will move on to a healthy node. This is done automatically. What if a node goes down? So if the node goes down, Kubernetes will detect that this node went down, and all the workloads that are there on this machine need to be moved to a different healthy machine. This will happen without you having to intervene in any of this process, right? Obviously, you will get insights into what is happening inside the cluster, but you don't need to do like right away. You don't need to fix it. So your application is still safe. So as an operations guy, I can sleep peacefully in the night, right? That's my end goal. So What if my node comes back? You can basically reschedule your workloads and all these things. So what if I want to patch a node? Let's say node 2 has some vulnerability, I need to patch that. All I can do is just execute this command. With one single command, I can move all the workloads on that node to a different healthy node, which is pretty nice, right? So I don't need to worry about like I need to boost up another machine. I need to change the load balancer rules. Everything is taken care by Kubernetes. So it comes onto the different healthy node. Yeah.
Just a quick question: does that movement when you're back here, is that like dynamic, like in motion, or is it restart?
So it's basically application gets killed here. A Docker image is pulled onto node 5 and then started. Actually, it's other way. So a pod is started here, or the application is started here, and then it is killed on here.
It's not like moving memory.
No.
Does it wait,
Moving as in,
does it wait for active processing to finish? Like
Yes.
It's like a web application. Does it wait till it's quiet, moves the protocol, and then does it?
so before it kills the application on this instance, it sends a sick kill signal, so that if the application handles a sick kill event, it can basically clean up everything, whatever it is doing. It can also send, I need some more time to exit, please hold on. It can do that as well. So all these things are handled inside Kubernetes. It's pretty good. I mean, it takes out a lot of effort from the operations side to do all these scripting from your day-to-day life, right? So it brings up a new instance here, changes the load balancer rule to point to this one, and then empties this one. So load balancer rules are also taken care of without you having to write a single line of code. All you do is basically execute this command. That's it, right? So if you want to expose this application outside of the cluster, you need some kind of routing layer, right? So routing layer is, it can be FI, it can be HA proxy, or it can be a cloud load balancer as well. Anything, okay? So basically you can hook up this load balancer directly into the pods, and basically everything, all the rules on the router will be updated automatically. You don't need to go and update.
Is that an external load balancer?
So there are multiple options here. Let's say you are using Kubernetes. You have to rely on some kind of object called ingress, or maybe a Google Cloud provider, or like they provide their own load balancers to hook up, or AWS have their own implementation. But in case of OpenShift, there is an on-premise based on HA proxy. So HA proxy will basically do that piece for you. Yeah.
Software defined network, is that Docker HCL, or is it like a
So Kubernetes has something called a CNI, like Container Network Interface. It has a lot of capability, like it's basically a specification, not an implementation, but whoever is satisfying their specification, they can have a software-defined network setup here. You can actually use Google provided network, like internal cloud provider network, or something like Calico, Open vSwitch, you name it. There is a number of vendors who provide for different use cases. You have different SDN providers. Yes, Open vSwitch is an open source option, and a lot of others are again open source as well. Kubernetes. The good thing about Kubernetes I love is everything is plug and play. You can swap out this, you can swap out registry, you can swap out like whichever suits your need, you can basically plug in that, right? Because every organization is different. Let's say some have very strict rules on how they deploy, and some they don't. Like some of them don't have. So everything here that we see are mostly like plug and play. You can take some of the components out and then plug in with something which suits your need, right? So, and when this also the routing layer also gives you a nice name. So as a developer, I don't need to wait on someone to provide these domain names for my application. If I want to do some quick proof of concept, I don't need to wait a long time to do all these activities. So you can see I got a quick route also that I can use for my testing as well. How this works is basically uses wildcard DNS to set that up. Okay, but you can also expose the node ports, like individual nodes, you can expose a port to outside world. That's totally possible. All right. So as far as the ingress point is concerned, so this is your entire cluster. As far as the ingress point is concerned, you have a lot of options to choose, whichever is good for you. Yeah.
So that's one of the things when you start looking at, say, DevOps operations or just the work development, is there's a separation because you've got some customers and or environments like some environments where DevOps, the dev team's taking all operations, they're doing all this. You already have a pretty mature organization. You have operations side and development side. There should be some sort of notification process to get those things over so you make sure that you still lock because worst thing happens is developer goes an application, goes to production, next thing you know, it burns down, no one else can control that developer and it's the outside. So that's one of the things you still got to keep sort of, we want Sandy to keep it separate, and also make sure there's mechanisms to make sure that the developers are keeping that code up to date and stuff.
So moving on, let's say we are talking about all the web applications, right? These are stateless, let's say microservices, pretty fine. If one application moves from this node to another node, it may not have any data, then it's totally fine. But what about persistent containers like, let's say, MySQL? What happens with them? Because when this MySQL container wants to move from one node to another node, there is a data along with that, right? So what about the data? So Kubernetes also has some capabilities for working with persistent storage. It's already built in. This storage can be anything from NFS to your corporate storage. I can name like 10 different storages right now. More are coming as well. So it can be Gluster, iSCSI, Google, PDisk, or AWS, EBS. There's a lot of options to choose from. Okay, NFS, and then Rook is another storage, Ceph is another storage. There are plenty of options on the Kubernetes side as well, right? So, yeah. Does anybody have any question? Right. Okay. So that's the persistent storage is basically like what if container moves from one node to another node, this will be unmounted from the node, this node 3, and mounted onto node 6, and then back to this pod again, right? So this is taken care automatically. You don't need to go and unmount there and then mount it there. As a developer, I just see, okay, this container moves from this node to another node. That's all I see, right? This happens behind the scenes, but we have all the visibility inside. And there is something you need for storing your Docker images. Like all these applications are Docker images, right? So you need some kind of registry, a Docker registry. Kubernetes doesn't have this. They kind of kept it open for everyone, but OpenShift has a built-in registry, right? And this registry is access controlled, like you can control who can push and pull images from that. And then monitoring as well, monitoring as in health of your entire cluster and also application monitoring, two aspects, right? So there are some very good tools like Prometheus for looking at your cluster health, and also Hawkler in case of OpenShift, and also like Hawkler APM. Again, there is a project on Kubernetes for open tracing to look at the like open tracing is like a specification again, but there are more projects that are coming up to implement that open tracing. Basically, tracing for your application itself, not for the cluster. All right. So, and logging as well. When these applications move from this node to another node, you also need to take care of the logging as well, right? Like, where does the log go? If this content moves from this to this, where are my logs? So these logs needs to be collected in a centralized logging system. You can use Kibana. There are plenty of solutions out there, right? So this is a typical architecture. Whatever you see in the like red thing is basically OpenShift, whereas like all the other things that you see, this persistent storage again is part of Kubernetes as well, but these things are mostly like Kubernetes, right? Yeah.
I have a question. It might not be the appropriate time. Maybe you're going to go over this in a minute. But a lot of times what we see in like data centers is you have rot over time. Does the monitoring here help with that at all? Like, so you're deploying, we're actually separating people farther away, so they don't know all the nitty-gritty details of a VM. They're just blindly deploying a container. So like if there's orphan persistent storage, or if there's just like a bunch of containers out there that are just no longer being used and get no traffic or whatever, are there ways to see that through the monitoring or whatever?
I mean, as far as the tools that I've seen, no.
No.
But the Kubernetes or OpenShift tool, like command line tool itself, will give you a garbage collector. You can execute that, like you can schedule a job on this, and then it goes and removes everything, like every orphan image. But as far as the monitoring tool is concerned, I've not seen one yet.
Okay.
May not be. I've not encountered, but not seen.
Fair enough.
So this is a architecture of Kubernetes / OpenShift. Any questions? Yeah. For rolling updates, I believe there is a PR. I just saw it somewhere on the GitHub. Not really went into the deep depth of what it is, but I've seen one PR for rolling updates. But as of now, I don't think it will. So for rolling updates of the stateful sets itself, I can't think of any workarounds, but I'll keep that in mind. Let's get that once it's done. I need some more time to think about it. There are plenty of options inside Kubernetes, like concepts. Probably one of them is Zool. Right. So this is a architecture overview. With that, I'm going to give a quick demo, and then we'll jump into the Kubernetes installation part. All right. So, like I said, Kubernetes is again almost same as OpenShift. So I'm going to use OpenShift if you don't mind. I don't have a Kubernetes cluster setup, but I'll try to. This is again open source project. It's not any closed source. Okay. So, all right. So this is what I have. Let me increase my font. So what we are going to do is we are going to deploy an application, scale it. We are going to do rolling deployment, update some change, how it gets reflected, all these pieces. Okay. So I have a bunch of nodes. Is this visible? Okay. So I have a bunch of nodes, 5 I guess. So one is infrastructure node, one is master node, and the other 3 are like simple nodes which actually host applications, right? This master is basically having like infrastructure components, but whereas actual applications are hosted on these 3 nodes. Okay. You can see master is scheduling disabled because it is master. So what I'm going to do is I'm going to deploy kubectl. So if you execute OC get nodes, it is same thing as kubectl get nodes, right? It's the same thing. What I'm going to do is deploy a Docker image from the Docker Hub. So I have a Docker image on the Docker Hub, which is like a Go application, but it can be PHP application, it can be Java application, anything, right? So I have this application. What I'm going to do is deploy that application. OC new app. Docker.io, go into my handle, and then deploy this application. So this is a Go welcome application. It doesn't have very